Now, friends, let us see the concept of limits. So far, we have discussed the basics of calculus, that is logarithms, trigonometry, and some sort of special functions. Of course, a few topics on geometry. Now, let us move to concept called limits. It is a very important concept, friends. Listen carefully. See, what do you mean by limit exactly? See, for example, I have a curve. This is f of x and this is x. F of x is nothing but the function of x, which is nothing but y. Suppose if I have like this. See, at a particular value a, I want to define what is the value of y. At a particular value of x equal to a, I want to know what the y value is. Suppose the value is equal to L. See friends, now this is nothing but less than a. This is nothing but greater than a. Suppose if at all the next value of a, that is which is greater than a, that is suppose a plus. I need this. This value is nothing but approximately equal to L, right? Now below value, the next below value of a, that is next one nothing but a minus, which is nothing but approximately equal to L, right? These two are tending to L. When x is tending to a, these two values are also tending to L, right? This is nothing but limit, friends. As x tends to a, both should be equal to, this is left hand limit and right hand limit, both should be proposed to only one. Both should approach to only same value. Then only you can say that limit exists. Okay friends, and it should be defined well. So this is the definition. A function f of x is said to have a limit value L as x tends to a. As x is tending to a, the value should be approaching to L. Right, so left hand limit when x is less than a, when x is less than a, that is nothing but here, and x is tending to a, when x is moving to a, then limit x tends to a minus f of x is equal to limit h tends to 0 f of a minus h. This value is defined. Now when x is greater than a, when x is greater than a, that is a plus, and x is tending to a, coming here, coming to left side, this value also tends to 0. When we change to h domain, that is nothing but x tends to a plus. See friends, limit h tends to 0 f of a plus h. Right friends, when h value is substituted 0, we will get f of a, right? What is the value of f of a here? F of a is nothing but, the f of a value is nothing but L, right? So L is the value. So in this way we say, but generally in order to say limit exists, in order to find the limit value, left hand limit should be equal, not be equal to right hand limit. When left hand limit is not equal to right hand limit, limit does not exist. We cannot say the limit value. That means there is a sort of discontinuity is there. That means for every continuous function only we will say a limit value, right? Did you understand? So whenever the limit exists, we will say there is a continuity. If there is no limit, then there is a discontinuity. Okay friends? Okay. See, now friends, let us discuss a very important point, which is called indeterminate forms. Whenever we are solving problems regarding limits, we have to aware of these forms. See friends, whenever you have 7 different type of forms, right? See, 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 0 power 0, 1 power infinity, infinity power 0. If at all a function, when you apply, suppose friends, limit x tends to a, f of x by g of x is there, suppose. When we apply x equals to a value and we are getting any sort of this format, see friends, then it is called indeterminate form. Then we have to change that limit by using L'Hopital rule. By using this rule, we have to change the limits. I will be telling you what L'Hopital rule is. Whenever this form, indeterminate form comes, we have, by using L'Hopital rule, we have to transform that limit and then we have to substitute and to find the value. So friends, these are the 7 forms of indeterminate values. These are not indeterminate value for indeterminate forms, friends. Don't get confused. 0 by infinity, no, this is not an indeterminate form. Infinity plus infinity is also not an indeterminate form. Infinity power infinity and 0 power infinity are also not indeterminate form, friends. Only these 7 are indeterminate forms, and for these 3 forms, especially not these 3, for especially 1 power infinity, there is a separate formula. I will be telling you that formula when I am teaching you the entire formulas for limits. So whenever these indeterminate form comes, use L'Hopital rule. Okay friends, so I will be telling you what L'Hopital rule is. Before that, let us see different formulas on limits. Okay friends, now let us see the important formulas on limits. Okay, see, first formula, limit x tends to a x power n minus a power n by x power m minus a power m. See, this formula is n divided by m, a power n minus m. X is tending to a. When we substitute the value of a here, this formula becomes this, right? Now, if at all m value is equal to 1, generally we used to see this formula from our intermediate case. We used to have this formula. Limit x tends to a, x power n minus a power n by x minus a is n into a power n minus 1. But originally it came from this formula, right? Now, second one, limit x tends to 0 sin ax by x, limit x tends to 0 cos ax. There is no x here under cos. Limit x tends to 0 tan ax by x. These three values are equals to a, right friends? Next. These are direct shortcuts. Remember these formulas. Limit x tends to 0 sin x degree by x. This degree is nothing but x power 0. X power 0 means x degree is pi by 180 into x radians. So pi by a 180 comes out. Right. Next one. Limit x tends to 0 cos x plus a sin bx whole power 1 by x. This is very important formula. Basing on this formula, once upon a time a gate question was framed. So limit x tends to 0 cos x plus a sin bx whole power 1 by x is equal to e power ab. Okay. Next one. Limit x tends to 0 e power mx minus 1 by x is m. Limit x tends to 0 a power kx minus 1 by x, k into log a to the base e. Right. Next. Limit x tends to 0 a power x minus b power x by x equals to log a by b to the base e. Okay. Next, limit x tends to 0 a power x plus b power x by 2 whole power 1 by x equals to root ab. Next, limit x tends to 0 1 plus ax whole power b by x root e power ab. Limit x tends to infinity. This is infinity, friends. Remember, until now we have discussed a's and zeros. Here it is infinite. 1 plus ax whole power x equals to e power a. See, these two are very similar formulas, friends. When a is here and x is in the numerator, here x tends to 0. When x is in the denominator, x tends to infinity. Remember, friends. Okay. So these are the main formulas. Now let us see other 10. Okay. See, friends, now other important formulas. Limit n tends to infinity 1 power k plus 2 power k plus 3 power k and so on up to n power k until this number power k by n power k plus 1 equals to 1 by k plus 1, friends. Okay, this is the formula. And when limit n tends to infinity, see, when at the place of 1 there is p here, some other value, when which is p greater than 1, then there will be 0. If it is only 1, then it is 1 by k plus 1. It is 2, 3, 4, any value, it is 0. Fine, when it is p greater than 1, right? Next one. Limit x tends to infinity 1 plus 1 by ax plus b whole power cx plus d is e power c by a. Fine. Now, these are all the proved values, friends. Just take them as granted. These formulas are very much useful for you. These are all shortcuts. Don't waste your time in solving the questions. Just remember these formulas and apply in the solution. Okay. Next one. Limit x tends to infinity a power x plus a power 1 by x plus b power 1 by x plus c power 1 by x by 3 whole power x. Okay. And this value is equal to limit x tends to 0. When infinity is there, power 1 by x will be there. Right? Right, friends? And this value will be cube root ABC. And see, friends, when limit x tends to 0, 1 power x plus 2 power x plus so on until n power x by n whole power 1 by x equals to nth root n factorial. So these are all very important formulas, friends. Just remember, these formulas, just take them as granted and don't ever get confused, friends, because see, friends, here this is a very simple thing. When x is tending to infinity, this will become infinity, right? And this will become here 1 by x, friends, power. Okay, a power x plus b power x plus c power x by 3 whole power 1 by x will be there here. This will be this value becomes, both these two values becomes cube root ABC. When there are ABC here, cube root came. AB plus d power 1 by x, 4th root ABC will come. Like that 5 terms here, 5th root ABCD will come. In that way, you have to move further. So, whenever 1 by x comes, infinity will be there. Whenever 0 comes, 1 by x will be there. Here x will be there, right? Just remember that. Next, limit x tends to 0, 1 power x plus 2 power x plus so on n power x by n whole power n 1 by x. This is nth root n factorial. Okay, next one. Whenever I have already discussed the indeterminate forms, in that I have told for 1 power infinity format there is a special formula. Limit extends to a f of x g of x, take this as granted. E power limit extends to a g of x into f of x minus 1. 1 power infinity means minus 1 will come here, just remember in that way. And infinity power infinity, 0 power 0, infinity power 0 format, here limit extends to a f of x g of x value is e power limit extends to a g of x and log f of x. Don't get confused to do these two formulas, friends. Whenever 1 power infinity, f of x minus 1, infinity power infinity, infinity power 0, 0 power 0 is g of x log f of x. This format comes, right? And now this is nothing but signum function, right? Bracket x by x. So limit extends to infinity. When is signum function, when x is tending to infinity, what is the value of signum function? 1. Next, limit extends to infinity, bracket function ax plus b by x is nothing but this coefficient a comes. Next, what is the, when x is tending to 0, what is the signum function, friends? Does not exist. Why? In signum function there is a discontinuity at x is equal to 0, right? This is the discontinuity at x is equal to 0. At x is equal to 0 there is a discontinuity, so there is no limit, so does not exist. Next, when it is infinity the value is 1, when it is 0 does not exist, remember that. Next, limit extends to a x power a minus a power x by x power x minus a power a equals to log e by a divided by log ea. So these are the formulas. So next one, 20th formula. Now an important formula, friends. See, if the degree of f of x is greater than g of x, that means here the degree of this polynomial function is 3 and the degree of this polynomial function is 2, so the numerator degree is higher. When degree of f of x, that means this, if this is f of x and this is g of x, and if the polynomial function of f of x greater than g of x, then this particular limit when x is tending to infinity, definitely it will be infinity, friends. Okay, no need of solving the problem, take it as granted. Next, if degree of f of x is less than g of x, here if this is f of x and this is g of x, right, when x tends to infinity, degree of denominator is higher, then the value becomes 0, then the limit becomes 0. If both the degrees are equal, this is 2, this is 2, then the result will be quotient of numerator by quotient of denominator. The quotient of numerator of x square, the quotient of x square in the numerator, and the quotient of, that means the first term, this term divided by this term, friends, 2 by 5. This is the shortcut. So remember these three, friends, these three are very useful for you, and it won't take any, if you remember these three, no need of solving the question, right? So have them. So now, friends, up to now we have seen the formulas of limits, right? Now let us see the properties of limits. Okay, see, first one, limit extends to a c into f of x, where c is a constant, 5, 6, 7, something, some constant is there. That constant can be come out, c into limit extends to a f of x. Second one, limit extends to a f of x plus or minus g of x. That means when limit is applied to either addition or subtraction of two functions, we can say limit extends to a f of x plus or minus limit extends to a g of x. That means we can split the limit, right, friends? Next one, limit extends to a f of x into g of x. Here also we can split the limit. So limit extends to a f of x into limit extends to a g of x. This is one of the important properties. These two properties we generally use it very often, right? Next one, limit extends to a f of x by g of x. This is also we very often we used to use this, friends. So limit extends to a f of x by limit extends to a g of x, provided limit extends to a g of x should not become to 0. When it becomes 0, the function will be infinite, right? So it is not 0. Next, limit extends to a f of x whole power n. This limit can be useful to limit extends to f of x whole to the power of n. So in this way also we can use limit extends to a nth root of f of x. This limit will go to f of x function, friends. Next, seventh one, limit extends to a constant. There is no function, right, in order to substitute a, so the constant same will come. Next, if p of x is a polynomial, then limit extends to a p of x is nothing but substitute a in that polynomial. Simple. Fine. So these are the very important properties, friends. Basing on these formulas and properties, we move to further gate questions. Let us see those questions.